First three. Reflexive, symmetric, transitive. These are the first three properties of equality I'd like you to write down. Okay. I'm going to put a little line underneath it. All right, for these three are used more or less in geometry types of proofs, not algebraic proofs. Don't get me wrong, they are sometimes used, but they're not the most common. You'll see them a lot when we get to the geometry proofs, like prove that these two shapes are equal, or so on and so forth. So those are things we're eventually going towards, okay? The ones at the bottom, the addition, multiplication, subtraction, division, those next four, actually the ones we're going to use quite a bit in here, okay? All right, what I want to talk about today, got a pass for me? Yes.
What?
Got a pass for me?
No, that's in the bathroom.
Okay, that's 10.
Huh?
10 for me. We already knew where you are. You gotta get rid of this food though.
Huh?
You have the food, remember?
See, I didn't have this.
Nope, not at all. Okay. So goal today, I'm going to go through these pretty quick. Pay attention, write these examples down for the reflexive property. Anytime that I give you a problem like this is the one we did yesterday, okay? And the simple fact that you wrote it down in your notes, if you didn't, you should write it down now. If you didn't have it in your notes from yesterday, that simple idea that you just copied it, that's a reflexive property. It's writing something down exactly like a mirror image. Now, in proofs, it could be, maybe I don't give you an equation, like this is an equation, right? If I don't give you an equation, let's say I give you an expression of some type. So maybe it's something like this: 5x plus 7 minus 3x plus 10. Maybe I give you something like that. And you simply write this down, but you write it down and you set it equal to itself. Because what you're going to figure out is when we do expressions, I always like you to start with this. You start with the original problem over here. You put an equal sign, you repeat it, and that's the reflexive property. And then from there, we do all the math, we do all the steps to simplify that problem out. We learn all the math, and that's what we're learning today. Like, what are the steps you do to actually simplify this thing correctly, so you're not missing any steps? Because I guarantee everyone can look at that problem and go, it's 2x plus 17. Like, I know you know the answer. The problem is, you skipped about 6 lines of work between there. So you gotta learn the real math behind it. The goal today is to intro you into actually doing correct steps. Okay, and we're gonna try some out together today once we get there, okay? But the goal today, what I wanna do first, for the first 10, 15 minutes, is to introduce the properties, because you've never seen the words before, so you need to see them. So the reflexive property is just simply copying something over a direct mirror image and starting it. So this is the reflexive property. Make sense? Symmetric property is anytime you start a problem and you're gonna change the look of it. So here's what I mean by it. I'm gonna go back to that original problem I gave you yesterday. In fact, so if you haven't already, anyone still need the reflexive thing here? You should be writing these down. You actually get out notes. Those down. You can get last one. Actually come with stuff you're going to now. So reflexive property, you're going to start with the problem, you just repeat it again one more time. But symmetric is when you start with a problem, let's say like the 10 equals 3x plus 1, and you're going to immediately flip it around, because most people, like in algebra, they don't like the variable on the right side. They hate it. It's one of those things that's a little pet peeve. It really doesn't matter, but it's a pet peeve for somebody. So what you need to do is you need to flip the actual problem around the right and left side. They have to flip. So 3x plus 1 equals 10. You have have to flip it. That's a symmetric property. In fact, I'm gonna write that down. The simple fact that I switched the entire right and left side, notice the equal sign is still there. I didn't actually switch numbers, like I didn't like move like the numbers, the 1 and 3x around. I just literally took both sides of the equal sign and flipped the tiles to the right and left side. That's symmetric. Now, why you'd ever want to do that is because maybe, they gave you the problem in the book, and it was the 10x plus 10 equals 3x plus 1. And eventually, and I'm going to leave that there because I know some of you are still writing it. Eventually, they wanted the answer that x equals 3. That's the answer they wanted. They actually asked you to prove x is 3. So they already gave you the answer. Like, we already know it's 3, but you have to show all the steps in between. Well, if you notice, if they started you here and they ended you here, the variable ended up on the left side. So at some point, you had to switch the two sides around like I did. Now, I don't know which line of work you did it. Maybe you switched it when it was 9 equals 3x and you suddenly switched it, and then you went from there. But at some point, you had to perform the symmetric property, where you actually changed the right and left side around. It's just, the properties of equality work when you have equations, right? You have something where there's an equal sign and you're doing something over it, like the reflexive property. You're setting something equal to itself, reflecting you. Or you just, the mere simple fact that you copied it down in the first place. That's everything, that's reflexive property. All right, now transitive. Transitive, I'm gonna use this example over here as my transitive property. Does anyone still need this? Yeah, okay. All right, the transitive property is when you actually do all the work and you do all the steps in between. I'm not even gonna write these down, but you do all of this work and suddenly you get down to the final answer where, because this thing we're not, it was just an expression, so we're simplifying this all down and eventually you ended up with 2x plus 17, right? That's what you ended up with when you actually combine like terms, combine the x's, combine the numbers, right? But you skip a lot of steps in between, and I kind of warned you that. But what the transitive property is setting it equal to what you started with. So what I mean by that is like when you simplify an expression and you get all the way down to the end, and once you're done and you suddenly go, okay, I started with this, and it eventually equaled this. The simple fact that you understood like what you started with and what you ended with and you could set them equal to each other, that is the transitive property. It's skipping. It's the daisy chain of events. It's that law syllogism that we did yesterday, the chain of events. That one item led to a different item, led to a different item, to a different item, to a different item, but then eventually seeing the overview that whatever I started with eventually equaled the last thing. By the way, the book that we did yesterday, that I was talking about when I was talking about the law of syllogism with the paper clip carrying to a Lamborghini, is called One Red Paper Clip. That's what it's called, One Red Paper Clip. I'm going to add that book to my website so you can see it. I'm not trying to sell it because I don't have any promotions with it, but it was just a social experiment this guy did. But I did find the book. Actually, it wasn't even me, it was another student in period 3. Actually knew the book, actually read it. All right, questions with the 3 top ones. These are the ones that most people are probably never seen in your life. A reflexive where you set something equal to itself, symmetric where you flip the equation around, or transitive where you start with the beginning and you end with the last thing and you set them equal to each other. This thing will be more prevalent when we do geometry proofs. Like you start with something and then eventually you have to get it to equal something else and you set what you started with to what you ended with. That's very apparent in geometry proofs. Algebraic proofs, we really don't do that. More or less in algebraic, we do that stuff. Where you just try to get x is 3 or x is 12. That type of thing. All right. The next 4 properties are the ones that everyone knows. These are the ones that you do in Algebra 1. If you didn't know them, I don't know who your algebra teacher was, but they didn't teach any real algebra. It's the addition property of equality, the subtraction property of equality, and the division property. These 4 properties, even though they're called properties of equality, are the main properties in algebra that show you how to set up a problem so you can solve for x on an equation. And again, they have to be equations because duh, these are called the properties of equality. Equality is literally the short word for equation. These are the main four. So when you had a problem like this, x plus 7 equals 10, and the first step you took on that problem was to subtract 7. That's what they teach in Algebra 1, right? They teach that. What you're doing is the subtraction property of equality, because what was the first step that I had to do? What was the math that I just did? Subtract. That's why it's subtraction property of equality. Now, it is not going further. It is the simple fact that you said minus 7 minus 7. That's the subtraction property of equality. That's it. If you had a problem where it was like this, where it was x over 5 equals 2, right? You had that problem. And the first step you're going to do on your problem to get the x by itself is you're going to multiply both sides by 5. You're going to multiply both sides by 5, like that. Because the idea is that you always do the opposite of what the problem said, the original problem. So if the original problem says you're dividing by 5, you multiply by 5. The simple fact that you just said times 5 on both sides, that's the multiplicative property or the multiplication property of equality. It's not going further. It's not, canceling out the 5s, making a 10. That's all the other properties we learned. But this is the one for sure. You should have seen it. Maybe you didn't know the names of them, but this is the stuff you should have learned in Algebra 1. And I can show you all these examples where you can magically do something to both sides. And by the way, this is something that always weirds people out. You can do whatever you want to an equation on both sides. You don't have to multiply by 5. You don't have to subtract 7. You can actually do anything you want to an equation as long as you do it to both sides. Which is the weirdest thing for people to wrap their head around for the first time. Because you're so used to knowing the bare minimum number that you should use, mind you, to actually solve. But they forget the fact that what these properties actually say is that you can do anything you want. Like for instance, if I had 3x plus 1 equals 10, for just some stupid reason, I can multiply both sides by 2. Makes no sense. I can do it. I can just make up the number and go with it. Because it'll make equal things. It's the concept that if you knew, okay, so this is a different example by the way. If you had the number 17 equals 17, right? You agree 17 is equal to 17, the value of it. You can do whatever you want. I can multiply both sides by 2. They're still equal, as long as you did it to both sides. The analogy I always use with these properties of equality, it'd be something like this. This is the make or break moment, how you know that you're doing it correctly. Let's say I walked in this room, I separated the class to be half and half, and on one half of the room I gave you a homework assignment, and on the other half of the room I gave you pizza. There'd be riots. You'd probably try to kill me up here, right? Because it's not fair, right? I'm not doing the same thing to both sides of the classroom, right? This is the property of equality. You're balancing the act. If I'm going to hand out homework, I better hand it out to everybody. If I'm giving pizza, you better give pizza to everybody. That type of thing. You have to do the same thing. That's what those properties tell you. They don't tell you what's going to happen later. The simple fact that I brought the pizza, right? That type of thing. I don't have pizza, sorry. All right. Questions at all about these 4 properties? These are go-to properties when you have an equation. Did you hear that word? Equation. If your problem is this, I'm going to go back to that problem I wrote earlier. 5x plus 7 minus 3x plus 10. I think this is the problem I wrote up here earlier. Does that problem have an equal sign in it? You will never do any of those properties of equality. I'm not going to suddenly add to both sides. I'm not going to suddenly subtract to both sides. There's no both sides to this problem. I know that what I told you earlier is you could introduce an equal sign and then write down the problem again. But at no point in this problem will I need to drag something across the equal sign over here. So I'm never going to use a property of equality on this problem. I will simply use the other properties, which are called the field properties, which are the properties we actually use to do the solving. This stuff helps you set it up, right? The symmetric property, it switches the problem around. It didn't solve anything, but it was a setup to the problem. The reflexive property, it's a setup where I set two things equal to themselves. The transitive, where I set something equal to the last thing. It's a setup, it's not solving. These are the first step to solve an equation, but they don't actually do the work, the dirty work. Okay, questions with those? All right, so here's what I'd like you to do. I'd like you to write this problem down. X over 2 minus 1 equals 18. I'd like you to write that problem down. What I want you to do right now for 1 minute, not solve this, don't solve it. What I want you to do is write down the steps you know you're gonna have to do eventually to solve this thing. So there should be 2 major things on that list right there, those 4 that are in front of you, that you know you will have to do, and that's the only 2 I want you to write down. Okay, so what are the 2 out of this thing, right here, those 4, that you will have to do on this problem? That's all I want you to write down. Because we need to identify which 2 we're gonna do, and in which order we're gonna do it. That's all I want you to do, because we gotta practice this. I know a lot of you are writing, that's good. Okay, can somebody walk me through, what's the first step you think you have to do here?
Symmetric.
Okay, I wouldn't need to do symmetric, okay, because I don't need to switch anything around. That's not a crucial step to solve this thing. What would be a crucial step?
Add to both sides.
Add to both sides. What am I gonna add to both sides? 1. Okay, at some point, you know you have to add 1 to both sides to actually solve this thing. Now, the reason why, I have to get rid of that number right there. You have to add 1 to both sides, because adding 1 will eventually cancel. Okay, that is the additive property we call it. The addition property of equality. Prop of EQ. Okay, we know we have to do that one, right? Symmetric, not so much. That's only if like I had the X on the wrong side and eventually they wanted the X over here. I wouldn't probably need to do that. Okay, what's another crucial step that I know I'll have to do eventually to solve this thing? Notice I'm not even solving it. But what would be a crucial step? George, what do you got?
Times by 2 on both sides.
Yeah, because eventually I have to get rid of the 2, right? They're dividing X by 2. So eventually I'm gonna have to multiply both sides by 2, and that's the multiplication property of equality. Multiplication prop, I'm abbreviating, sorry, of equality. Now, let's talk about why they have to go in that order. When you solve equations, something with an equal sign, like an actual equation where there's an equal sign, you're equaling a number, that type of thing, we have this order. This is the order you do when you have an equation. I know it doesn't look like PEMDAS. It's not supposed to be. PEMDAS is what you do when you don't have an equal sign. It's called an expression. I have an equation here. So this is the method. It's called the inverse operations. So if you're that one person that's like, God, I don't know what to do first. Like when I start this problem, this thing. You go S first or A. S or A, that's subtraction or addition, whatever one comes first. Then you would have to multiply and divide. Then you have to do exponents or parentheses if you have them. And you go in that order. So I'm gonna have to look for adding and subtracting first. Well, that's what I did here. I added them to both sides. Because you always do the opposite of what they're doing on the problem. And that's why it's called an inverse. You always do the opposite of what they have. So if they had subtract 1, you add 1. If they divided by 2, you multiply by 2. But you have to go in that order like this. They kind of go in 2s, that's how it works. Okay, questions on those steps? Now, I know like if you're to do this, you're gonna get some weird numbers, fine, whatever. Okay, but I want you to see the steps you have to take to get there. Okay, questions at all? Notice, I didn't use reflexive, symmetric, or transitive. They're not used too often with algebra. They just aren't. These are the 4 that I usually use, the first like couple lines. Now there's a bunch of steps in between, but that's what I do. Okay. We're good? Okay, let's go to the next properties. Okay, now, we start getting into the point where we're actually solving something now. These are called the field properties. There is, I think, 6 of these properties. I highlighted them in red, the names. I have a bunch of extra stuff here that kind of explains what we're doing. These field properties, what they call the field properties of real numbers, are the actual properties we do to solve something, to simplify it down, to get to my final answer. The first one is called closure or substitution. That's the key word there. I put it in the air quotes. Substitution is anytime in the middle of a math problem, you're suddenly doing random numbers, like adding, subtracting, multiplying, dividing by random numbers, and you're replacing them with the answer. So like yesterday, when I was doing a problem, I think at one point in the math problem I had earlier, I had a problem where it was like 9 divided by 3, right? I think that was the problem we did yesterday. And in the next step, I simply said 9 divided by 3 is 3, right? That's substitution. The simple fact that you replaced 9 over 3 with the actual answer that it is. That's substitution. It's random numbers. Added, subtracted, multiplied, and divided. They could be decimals, they could be fractions. Now, here's the thing I need to warn you of. Not every step is substitution. There are 6 other properties on this sheet. Substitution is only the time when you do random, crazy numbers that are either added, subtracted, multiplied, or divided, and you replace it like you typed it in a calculator, and you had to get the answer that you substituted. You found a different symbol that should go there instead of 9 over 3. Because if you think about this is a weird way to think about this. This is a symbol that replaces this thing. That's all it is. So if you didn't even know how to do math in the first place, that's just a symbol. It's a drawing of something that replaces this. That's a very weird concept to think about. That's how my son would think about it. He's 4. He doesn't know math, but he gets the idea that you're putting a different object there in its place. That's closure. Now, we have to be careful in this one. Closure is usually used at like the last line of a problem. The last line. Oh, I'm substituting because I have to do the last form of math. Add 17. Okay, fine. Substitution. I'll write down the final answer. But it's not everything. And you'll see there's other properties coming up later that you'll be like, how is that different than substitution? Because there's special numbers in this chart. Okay, second one is called commutative. Commutative is not used too often. Here's the time when I use commutative. Commutative, by the way, the root word there is to commute. The word commute means to group and move. To group or move, right? So if you're in a bigger city, you commute to work, right? Like in the Twin Cities, they have a lot of traffic, so you commute to work. You get with all of your friends or your coworkers, you group in one vehicle and you go to work, you move, you group, move. Well, on the problem I wrote up here earlier was this one. Right? That problem. Notice there's no equal sign. I don't need an equal sign for commutative to work. For substitution, I don't even need an equal sign. It's anytime I just do random math in a problem. But on this problem, if you were to simplify or solve this problem, what would you do? Like, what are the common sense rules? If you were to if I asked you to simplify this thing down, what are you gonna do?
Add 5x and 3x.
Yeah, that is commutative. Exactly what she just said. You're gonna move the 5x and 3x because you know those are called what? Like terms. That's the term they always use in algebra. Just the simple fact that you understand the two that you should look at that add together, you're commuting in your head. You're moving things around. In this proof stuff, you can't just do it in your head anymore. You actually have to physically write this before you do it. That you actually grouped the numbers together. Were they there before? No, I moved them around. That's commutative. So that's commutative. Then from there, you can go on and try to actually add or subtract numbers together. You know, like the 7 and 10 back here makes 17, that's substitution, right? You added the numbers together. Here is a different property, we'll talk about it here in a minute. Because I know a lot of people just go, oh, it's 2x. Yeah, it's 2x, but you skipped a couple steps. But it's commutative. Now, commutative is not moving across an equal sign. It's not doing that thing where you added 1 to both sides. That's the properties of equality we did earlier. Commutative is just when you simply rearrange things if you need to. It doesn't happen too often. Like, there's not a lot of times in a big math problem you're gonna have something like that. So you might do it once, maybe. All right, associative. Let's get to that property. The associative property. The associative property is better known as the parenthesis property. It uses parentheses. In fact, I'm gonna write that order. How I remember how to spell it: parent, and then hesse. Parentheses. So parenthesis property. It's anytime you're going to change the parenthesis symbol from like a bracket to a parenthesis, or you just move the parenthesis, but you're not moving the numbers in them. I know that seems really weird. It's when sometimes on a math problem they might have something written like this. They might have something like that. Do I really need the parenthesis here? Like, can I even add these two things together? No, you can't, right? That one has an X, that one doesn't, so you can't add. So you're gonna simply just do this. You're gonna either get rid of the parentheses, that's the symmetric property, or the associative property. Or maybe you want to do this. Maybe you thought that you could move the parentheses back with the 3 and 4. The simple fact that you moved the bars or got rid of them in the first place, that's associative. Now, you're thinking, okay, well, that is not going to happen at all. It happens 100% of the time after you distribute. In fact, I'm going to rip that down. This happens after distribution. And I'm going to put in quotes. That is 100% guarantee. 100% of the time when you distribute a number through a parenthesis, you have to do the associative property right after it. Distribution is the 6th property, it's the last property. I'll show you that when we get there. But a lot of times, like, it's something like this, where they have a lot of bars, a lot of parentheses, and you're like, I just don't need them, get rid of them. Boom, that's associative, you just got rid of them. As long as that's correct math to do that. All right, we're good with the first 3. Because I know these are like probably brand new to you. I don't know if you've ever seen these. Substitution you probably have seen, but you probably haven't seen these other ones. Okay, the next 2 are called the identities. Now, these are the ones that people always ask me, Ward, that just looks like you're substituting. It's not substitution. What you're looking at here for the identities is when you use specific numbers, when you use 0s and 1s. So anytime you're using a 0 or 1, it's not substitution, it's going to be a different property. Question?
Is that how they do like coding on a computer?
Yes. It's a lot of identities. So lots and lots of identities. So for the main part here, for the additive identity, you can actually see it here. It's any time in a math problem that you're doing a problem where you're going to add 0. So like I show you this example. A plus 0 equals 15. Well, what's A plus 0? Just A, right? The simple fact that you just added 0 to something, you just did the additive identity. Add identity. You added 0. Does everyone see that I just added a number? But it's not adding random numbers, it's adding 0. Because the problem I showed you yesterday was this one. It does happen in this problem. You know, I subtracted both sides. We already said that's subtraction property of equality. This number over here made 0. It made 0. It doesn't just go away. It made 0. And the simple fact that I made a 0, or I'm going to use it later, like, because I'm going to add 0 plus 3x to make 3x, that was the identity. That just happened right there. So on normal equations, you will do it once, at least, if there's adding or subtracting. You're adding a 0 somewhere. You can't just get rid of numbers. They don't just cancel out. They actually make zeros. a misconception. Now, it looks like substituting. Like, Ward, you just added 0. That's substituting. We're just replacing with a new symbol. Identities don't change the answer. Did you see the 3x earlier? Yeah, it's not substitution. I'm not making up a new symbol. It was just reprinted. That's an identity. Identity means it's the same picture placed over again. A plus 0. I already had the A written down. I'm retyping it. That's an identity again. Because you're not making a new symbol to put there. If you multiply by 1, that's called multiplicative identity. We had to do that yesterday. On this problem where we eventually got down to this, because I had the 3x. Eventually I got down to 3x equals 9, and I divided both sides by 3. Find this division property equality, right? But this side turned out to be a 1 when I took 3 divided by 3. The simple fact I got 1. The next step, I'm going to have to multiply by 1. 1 times x is x. Right? Because you can multiply anything by 1. I don't need to divide by 1. If you multiply it, called multiplicative identity, you can get rid of it. Because anything times 1 is just itself. It's an identity because the symbol didn't change. It stayed the same symbol. I didn't have to come up with a new symbol to replace it with. That's substitution when you come up with a new picture. For some reason, these really get people. They're always like, oh, I substituted. Multiply by 1, right? No, they're identities. They're not changing anything. But there's only 2 identities. It's adding or multiplying. You would not believe, because right now you're seeing, you will not believe how many people will get these wrong, because they're going to do this problem and go, oh, I just multiplied. That's multiplicative identity. Did I just multiply here? No, it's add. The symbol's right there. You know the symbol's adding. Call it an additive identity. You laugh now. It's going to happen. I'm going to have at least half of you in here that's going to be multiplying on a test. When it should be adding. All right, let's go to the next one. I only have a couple more problems here. We're almost done today. The inverses. There's 2 inverses here if you can see them. They have very distinct names. They're called the property of opposites and the property of reciprocal, which I just call a reciprocal property. But these are the inverse properties. This property is also mistaken for substitution. Because if you look at the picture, if you look at what I'm doing here, it's anytime you make a 0 or you make 1. So it's not substituting. Substituting is when you make up random other numbers. Zeros and ones are very special in mathematics, even in programming it's special. So anytime you make zeros and ones, that's a specific property name, or you use a 0 or 1, like you added a 0, that's additive identity. If you multiply by 1, that's multiplicative. But these are the simple fact that I made it in the first place. So like when I went back to this problem here, right, this is the problem I had up here earlier, and I subtracted 1 on both sides, right, that's the subtraction property equality. The next step was making 0, right, 1 plus -1, or 1 minus 1, however you want to think of that. That made 0. That simple fact that you made 0 here in the first place, before I even use it, the simple fact you made it is called the property of opposites. Property of opposites. The simple fact I'm adding numbers together to make 0. You have to do that if it's an adding or subtracting problem. It will make 0. They don't just cancel, they make 0. So if I did that, I think I had a problem up here earlier. I don't know what I had. It was something like this, wasn't it? I had this up here earlier. I had to add 7 to both sides. This will make 0. That's the property of opposites. It doesn't just cancel it. It makes 0, and then I'll use the 0 later for adding the added identity. So usually, so maybe you need to make this little note to yourself. You will do one of these 2 inverses first, and then it will be immediately followed. This will be immediately followed by an identity property. Because you will make the 0 or the number 1, and then you're going to use it on the next step. So this will be immediately followed by the identities, the 2. Now, reciprocal is anytime you divide numbers. So you can see it there. I tried to make an example where I had this problem up here earlier, where I divided both sides by 3, right? That's division property equality. But this number, when I take 3 divided by 3, and I actually made the number 1 in the first place, the simple fact that I made 1, that's the property of reciprocal. You're making the number 1, that's a special number. But notice how you do it. It's either you're adding or subtracting, or in the second one you're either dividing to make them. There's nothing else you can do. I don't care that you added 16 and a negative 15 to make 1. That doesn't count. It's when you add numbers together, or subtract numbers, I don't know how you're thinking about it, to make 0, or you divide numbers to make 1. These are the only 2 cases you have. Or, what was that problem I had up here earlier? It was it x over 2 or something like that? I don't remember the exact problem. Where, I don't remember what I had up here earlier. It was something like it was x over 5, I think it was a 5, equals 2. And I multiplied both sides by 5, I wrote that up here earlier, that's multiplicative property. The simple fact that I'm multiplying by 5, this eventually makes 1. That's a reciprocal again. Even though I multiplied both sides by 5, this was going to divide to make the number 1. We always say they cancel, but they make 1.
What?
Hmm?
I got so confused.
That when it's x over 5, you have to multiply both sides by 5. This turns out to be 1, because the 5 multiplies to the top, and this is what you have.
Okay.
That's actually how you do it. And so you are actually dividing these numbers to make the number 1. That's the reciprocal. That's that last property right there.
Okay, I guess.
Yeah, because anytime you take a whole number times a fraction, you actually just multiply it to the top. That's actually what you do. All right, and the last property today. This is your last one. It is called the distribution property. It's called the distribution property. So anytime you're going to multiply a number or a variable through a parenthesis, but most people have the wrong misconception of what this is. Okay, I know we only have like 30 seconds left. When most people look at this problem, how are you supposed to do it? Distribute, which means what? What do I do with the 3?
3 times x.
Yeah, 3 times x and
3 times 1.
3 times 1. Most people will automatically go 3x plus 3. You skip some steps. Distribution is just doing this. You're handing the 3 to each number. It's not multiplying yet. It's distributing. It's like the mailman is actually a distributor. That they're going to distribute the mail to your mailbox. You open it later. You multiplying the numbers in and saying, oh, the answer is 3x plus 3. The mailman opened your mail for you. Now we have a problem. They're simply a distributor. They're handing it out to you. All right. Now I know we have 30 seconds. And all that writing you just did, I have the properties already printed out for you. Oh, that was just evil. All that writing, you have all the properties on the property. You have back. Now, you cannot write on this piece of paper. You will be able to use this on your next test, which is coming up as early as next Wednesday. And don't tell the other classes what I just did to you. They're going to suffer through it too.
Oh my god. So mean.
It's so practical, take my wonder this.
Abby Christian, Matt Barrickman, and Ben First, please come to the office. Abby Christian, Ben First, and Matt Barrickman.
What?
If glass is color, why do we call it color people?
That's the best question.
Question of the day.
Number 15, question that science can answer. Number 15.
Is water wet? I know water is 8 different websites. Water is not wet. Google says it's not wet. The thing is, Siri says water.
15 questions, science.
I disagree.
No, Siri uses Wikipedia on it, so it's not wet.
That's it for the white. Just give me.
Your opinion? Water is the sensation of which you get
Hey, I need to talk to you, so you need to come up here.
No, someone's
No,
making
like
the
actually,
water
you
is
come
wet
up here.
argument. Come back
Let's
up.
start tomorrow.
Well, I want to sit next to you, but Lily's gonna sit next to you, so.
Yeah, exactly.
You can sit next to me, girl. Lily can sit in front of me. Who you want?
Ooh, you're on.
Let's sit in front of me.
I don't want to sit next to Lynn. Thanks, Wade.
What?
Are you? It's gonna take you way longer. You have to write a lot.
So,
I'm gonna have to write like how long.
it can only fit, but if you it can only fit 4 instead of 6. But 4 extra.
Jay has an 8 chapter.
Do it with the scale.
Yeah.
I will remind you.
Oh, there is so much
You
writing.
can write, you
I need
can
to
still
do
write
this.
with me. I might have to take a card instead of the cross.
Your opinion, Abby?
Why is there an extra?
So you write the card, she'll write the
I don't know.
So you write the 2, you're gonna write this, I'll write
Because
this.
there is a lot of writing. Way too much writing for one assignment. Way too much writing for one assignment.
You're gonna say what? So
If she's not going. We can.
Okay. Homework due. Homework's due in one of the baskets, front or back. Okay. Homework's due, front or the back. So keep that in mind. Yes.
Because, right, there's a wedding. And we're not going to wedding, so I'm gonna just
Okay, I'm gonna take attendance here. I would like you to have your notes out right now and be writing these 3 properties down in your notes, please. We're going to go through a lot of stuff very fast. The more we can get this written down, the better it will be for you.
I didn't do it to realize, no. And then I didn't have a towel. I did it like, oh.